A year ago, if you told me every data structure could be drawn exactly the same, I wouldn't have believed you. I only have 4 on the screen right now, and even these look different. But it turns out, if you look at things right, you can actually draw all of them like this. It works on any data structure, and it also works on any problem, easy, hard, academic, you name it. By the end of this video, you'll know how this works and where it comes from. But first of all, why don't people use this view? Why haven't you seen it before? And I genuinely think the answer is just that people aren't aware that it exists, because it seriously makes solving problems way simpler, and it really describes very well what's going on in Python. So pretend we know nothing about data structures. How can we come up with this? What we have to do is actually think about what's going on inside of computer memory. Computer memory is just a giant sequence of ones and zeros. So for now, let's just work with the example where we want to store this data. What the computer is going to do here is it's just going to translate this to binary and store it in memory. And the computer is also going to hold on to the fact that x is located here. Now when you go to read from x, say to read the second index, the computer will go to x, and then it'll jump to the second index, and then give you whatever is there. In this case, it's going to give you 8. That's what's going on behind the scenes, but actually, as programmers, we don't care about memory addresses, and we don't care about the size of each number. All we really care about is that we can go to the x, and then to any of the elements, like this one. And so all we're going to do is show that as a picture. This picture shows you that you can step to the x, and then once you've done that, you can step to any of the elements, like this one. So now I hope this view is starting to make sense. It just describes what we as programmers care about. Okay, so one more example. Say we want to store an array inside of an array, like this. It doesn't really make sense to put the array right here, because theoretically it can grow and shrink and bump into the other elements. So instead of doing that, it's going to store the array all the way out here, and then it's going to store the memory address that it should go to find that array. As programmers, we don't care about any of this address stuff. We only care that we can go to the x, and then we can step to the 2, which is this array, and then we can step to the 0 or the 1. So I hope this is starting to make sense now. This picture right here is just telling you the steps you're allowed to take in computer memory. It applies to all data structures because all data structures obviously live in computer memory. So just to do a recap of everything we just covered. We can store data, and that looks like this. Or we can store things that let you step to other data, and that looks like this. So these are the 2 building blocks for any data structure. Every data structure you'll ever encounter is made of these 2 things. That's why all of these data structures look so similar. And we drew numbers here, but these don't have to be numbers, they can be anything. If you understand the properties of these 2 things, then you understand every data structure. And you already know how the computer reads from them. If it's standing here, it can just walk along any arrow. That's literally it. In the next video and lesson, we'll go over what happens when you actually write to the data structure. And then that's literally it. That's everything you need to know to describe data structures in this unified framework. I put a link to the Derive It page where we show all the pictures for every data structure, and we also have a cheat sheet that shows you all of these in Python. So I really hope it helps, and I'll see you next time.